See, today I'm going to explain about the graph data structure. So first of all, from binary search tree, so what is the graph, where we use, how to construct the graph, all the things I'm going to explain. We have seen the binary search tree. Binary search tree is also is a connection of nodes from the specific node. But in binary search tree, one node can have maximum of 2 nodes only. That's why we can call it as binary. Maximum of 2 nodes only it can have. This is binary tree. Then what is the graph? In a graph data structure, one node can connect to any number of nodes. There is no limitation. This is connected to this, is connected to this, is connected to this. One node can connect to any number of nodes. There is no limitation. It can connect to this. This is actually called a graph. It can connect to this also. Is actually called graph. See, what is the simple example of graph? The best example is what? Just mapping. If you want to move from one location to another location, each place we simply consider as one node, one location to another location. In how many ways we can travel? See, in maps, in Google Maps, if you want to travel from one location to another location, number of paths are there. By connecting all these paths, right, we can explain that which is the shortest path, which is the longest path. Okay. And in different aspects like tolls, without tolls, and all the things. That is what connectivity of nodes. But sir, how can we construct this? But before that, simply if they ask, graph is a non-linear data structure. We know that nothing but non-linear means what? One element connected to any number of elements. Here, these things are called nodes 4, 5, 3, 2, 8. These are called nodes, and the connection between the nodes called edges. Nodes also called vertices. The connections between the vertices are called edges. Okay. Two types of graphs are there: directed graph and undirected graph. See, the directed graph means what? Just there is a direction from node to node. Undirected graph means what, sir? If there is no direction, simply to say it's a bidirectional, two-way direction. If you are not representing the direction, it is called bidirectional graph, two-way directional graph. One more example is a server is connected to number of clients. That is also one example. How can we represent a graph like this? Set of vertices and edges is a graph. So what is that? Adjacent is a path and all. How can we represent a graph? Using the adjacency matrix. Look at this. This is that A, vertex A is connected to B. See, sometimes self connection is also there, but here it is not there. So A to A is not there. A to B is there. A to B. A to C is there. A to C is there. A to D is there. A to D. But A to E direct connection is not there. So that's why 0. For example, from E, see, from E, only for B and D connections are there. From E, only B and D connections are there. Just B and D. Got it? And next one, D, connecting itself also. Look at this, D is connecting itself also. Remaining all are not connecting themselves. Only D connecting itself. So the easy way of representing the graph with the adjacency matrix like this. And in a graph, two types of traversals are there. That is called breadth first search and depth first search that I'll explain. But before that, how can we represent the graph? This is a very, very important point. First, I'll explain today conceptually. Then in the next class, we will implement the program. Normally, generally thinking that if it is binary search tree, if it is a binary tree, a node can have maximum of two connections. Maximum of two connected nodes. So simply you can create the node structure like this. Node, one is a data, second one is a left node, and second one is a right node. So whenever you are allocating the memory, that node creation is like this. Is a node creation like this. Is a data, is a left node, and is a right node. Is a right node. Maybe if the left node is there, okay. Sir, if left node is not there, it will be null. If right node is there, okay, right node is there. Else right node is also null. So easily you can represent this one. Easily. But in a graph, how can you represent? Is a one node can connect to any number of nodes. There is no limitation. Two nodes, okay, like this we can connect. Sir, third node also I want to add. Sir, fourth node also I want to add. Then how can you decide this size? Are you connecting to 1, or are you connecting to 2, or are you connecting to 10? Are you connecting to 10? We cannot decide. Okay, we cannot decide this one. So that's why easy representation first I'll explain. Suppose this is the node. If you want to connect this, for example, like this, these are the nodes. If you want to connect from this one, and this one, how can you connect? I'll explain. The node, suppose this is the node, and here it is a 3 more nodes are there. 3 more nodes. 3 more nodes. Here, right. Right. So why 4? I'll explain. One is actually data. 10, 20, 30, 40. 20, 30, 40. Okay. Suppose this is the data part, consider 10, 20, 30, 40. 30, 40. This is actually called data. Second one is a status. What is status? Actually, this status is useful only when you are understanding BFS and DFS. BFS and DFS. Okay, traversal concept, not now. Visited node and unvisited node. To check, to understand the node is visited or not, the node is not visited or not. Whenever we are learning BFS and DFS, you will understand. Now the question is, suppose as soon as that node is created, 1000, 2000, 3000 and 4000. Suppose nodes created like this. But problem is, sir, how can I connect multiple from one location? It is not possible to connect. That's why edges are there. This is actually called edge. Is actually called edge. Edge contains two fields. Suppose this edge address is a 1500 consider. First, this 1500 we will connect from this one. Half edge is connected. Then remaining half 1500 will connect it to this 2000 by holding this one. Is connecting to this one. Edge. Sir, now second one I want to connect, then one more edge. One more edge. Suppose this value is a 2500 consider. This 2500 we are connecting here. And this remaining 3000 we connect here. We connect here. Sir, one more edge I want to connect. I mean, one more node. How many nodes you create? Connect those many edges you have to create. This 3000 you will store here. 3500. And this 4000 you need to store here. Is connecting to this one. Is connecting to this one. See, nothing but normally we represent like this. But what is the actual representation? Suppose these are the three nodes. Is connecting with three edges. Three edges is connecting to this one. Second one is connecting to this one. Third one is connecting to this one. This is actually that actual representation. We code like this. We code like this. So now, how many required? How many required? So now here it is 2. One is a vertex. One is a vertex. Second one is a edge. Second one is a edge. Observe this. In the vertex, every node has 4 fields. Data field and status fields are integer fields only. So integer, one is a data field. Second one is a status field. Next one, see, this is very, very important. Sir, 1500 you are storing. 1500 is a edge node. Edge address, na? Edge address. So this one, edge address is there. Edge. Some address, adjacent I'm taking like this. Observe this. In this node, we are storing the address of edge. Address of edge. That's why. Next one, fourth one is there. Sir, what is this fourth one? Actually here, for temporary connection, just like linked list, we connect like this. Just like linked list only, not more than that. Nothing but 2000 we store here. 3000 we store here. 4000 we store here. This is also you will understand whenever we are writing the code for this. Just for temporary connection. Later, as means what remaining connections we do. Because first we create how many nodes are there. Suppose all the nodes we create. But how you connect how many nodes? That's why one temporary connection connecting to all nodes. After connection, then we start, okay, for first node, how many connections? For second node, how many connections? For third node, how many connections? For fourth node, how many connections? Like that we will represent. That is the one, this is same, vertex only. Vertex is a next link. This is representing this vertex. See, what is this meaning? This is called vertex. This is called vertex. It has how many fields? It has 4 fields. It has how many fields? It has 4 fields. That is. Okay. Now, thinking about the edge. This is edge. Edge. How many fields? 2 fields. Sir, what is the first field? See, first field is holding 2000. 2000 is which one address? 2000 is a vertex address. Is a vertex address. So the first one is vertex. Vertex address. So anything, suppose is a link we are creating. Vertex link. What is the second field? Second field is 2500. So 2500 is address of another edge. Edge, same edge only. So here it is edge. Edge, adjacent. Look at this. Inside the vertex, vertex link. Inside the edge, edge link. Because one vertex hold the address of another vertex. One edge hold the address of another edge also. Another edge also. This is actually the physical representation of a graph. Normally for other things, only one word, only one node representation is enough, like a class. But here it is, we need to create 2, not 1. Right? One is representation of vertex. Second one is representation of edge. This is the way. Okay. Today, only in the document what I have shared, already representations are clearly mentioned. See how it is storing and all. You please try. See, this is the vertex and this is the edge. This is the edge. This is representation. This one we are representing like this. Like this. Okay. And this one we are representing like this. You need to try to understand this one. Tomorrow I'll explain the program clearly. After that, we go with the traversals. Okay. I'll upload the video quickly. You just go through that.